In this lecture, I am going to discussing about the example problem on LP model formulation. Let's see the problem. Consider the following problem faced by a production planner of a soft drink plant. He has two bottling machines A and B. A is designed for 8-ounce bottles and B for 16-ounce bottles. However, each can also be used for both type of bottles with some loss of efficiency. The manufacturing data is as follows. Here it is given the machine A and B for production of 8-ounce and 16-ounce bottles. The machines can be run for 8 hours per day, 5 days per week. The profit on 8-ounce bottle is 1.5 rupee and on a 16-ounce bottle is 2.5 rupee. Weekly production of the drink cannot be exceed 3 lakhs bottles and the market can absorb 25,000 8-ounce bottles and 7,000 16-ounce bottles per week. The planner wishes to maximize his profit, subject of course to all the production and marketing restrictions. Formulate this problem as an LP model to maximize the total profit. Let's see the solution. First step is identify the decision variables. In general, decision variables are products to be produced by a company. For this, we have to read the data which is given in the problem. Here it is given the production of soft drink. So, there is no clarification on the decision variables. Then we can be identify these decision variables after the formulation of objective function. Then we have to go for the second step, that is identify the objective function. We know that objective function of any organization is profit, cost, sales, etc. Then we have to look for these words. Here it is given the maximize his profit. So objective is maximize the profit. Moreover, another sentence is given in the data related to the profit. That is, the profit on 8-ounce bottle is 1.5 rupee and on a 16-ounce bottle is 2.5 rupee. So, maximize Z, that is total profit. So, maximize Z equal to 1.5 rupee on a 8-ounce bottles and 2.5 rupee on 16-ounce bottles. So, maximize Z equal to 1.5 into number of units of 8-ounce bottles plus 2.5 into number of units of 16-ounce bottles. And we know that objective function is involving with the decision variables. So, here decision variables are x1 equal to the number of 8-ounce bottles to be produced weekly, x2 number of 16-ounce bottles to be produced weekly. Here data is given in the weekly, so consider the x1 and x2 are the number of units of 8-ounce bottles and 16-ounce bottles to be produced weekly. So, maximize Z equal to 1.5 x1 plus 2.5 x2. Next step is identify the constraints. For this, observe the data which is given in the problem, that is another sentence, the machines can be run for 8 hours per day, 5 days per week. So, availability of machine time is 5 days, in each day having the 8 hours. So, 5 into 80, that is total 40 hours. These 40 hours I have to convert into the minutes. Then the availability of machine time is 2400 minutes. Next we have to observe the machine time of machine A which can produce the 8 ounce and 16 ounce bottles. First I have to look for the 8 ounce bottles, that is 8 ounce bottles are 100 are producing in 1 minute on a machine A. Then time for 8 ounce bottles is 1 by 100 and the time for the x1 units of bottles is x1 by 100 minutes. Similarly, time for the x2 bottles on a machine A is x2 by 40 minutes. Here availability time for the machine A is 2400. Then the machining time point of view, constraints are the x1 by 100 plus x2 by 40 less than or equal to the 2400. Similarly, machine B point of view, constraint is x1 by 60 plus x2 by 75 less than or equal to the 2400. Next, observe the data, that is weekly production of the drink cannot exceed 3 lakh bottles. So 3 lakhs bottles of the 8 ounce as well as the 16 ounce bottles. So weekly production point of view, constraint is 8 ounce bottles plus 16 ounce bottles should not be exceed 3 lakh bottles. So x1 plus x2 less than or equal to the 3 lakh. So next, observe the market can absorb 25,000 8 ounce bottles and 7,000 16 ounce bottles per week. So marketing point of view, constraint is x1 greater than or equal to the 25,000. Similarly, x2 greater than or equal to the 7,000. So this is the solution, and thank you.